Hello friends, welcome to my channel. We are going to state and prove a squeeze theorem and discuss some examples. So, a statement of the squeeze theorem is: let f, g, h be functions defined on the domain D, and let fx is less than or equals to gx and less than equals to hx. For every x in D, let limit x tends to a, hx equals to limit x tends to fx equals to L. Say that limit x tends to a, gx exists, and limit x tends to a, gx is also equals to limit x tends to a, fx, and this is also equals to L. So we are going to prove this theorem by epsilon delta definition or formal definition of the limit. So proof, since limit x tends to a, fx equals to L, and limit x tends to a, hx equals to L, we have given. And also, so by definition, for every epsilon greater than 0, there exists delta 1 greater than 0 such that 0 is less than mod of x minus a less than delta 1, mod of fx minus L is less than epsilon, and 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 for every epsilon greater than 0, there exists delta 2 greater than 0 such that 0 is less than mod of x minus a less than delta 2, and hx minus L is less than epsilon. So again, if we take delta equals to minimum of delta 1 and delta 2 greater than 0, then the x satisfy both inequality. So for every epsilon greater than 0, there exists delta equals to minimum of delta 1 and delta 2 greater than 0 such that 0 less than mod of x minus a less than delta implies mod of fx minus L is less than L epsilon, and mod of hx minus L is less than epsilon. So these inequalities can be written as for every epsilon greater than 0, there exists delta greater than 0 such that such that such that 0 less than mod of x minus a less than delta implies fx is less than L plus epsilon and greater than L minus epsilon. Also hx is less than L plus epsilon and greater than L minus epsilon. Also we have given that fx is less than or equals to gx and gx is less than or equals to hx. So these, combining these inequality, we can write this as L minus epsilon less than or equals to fx, and fx is less than or equals to gx, and gx is less than or equals to hx, and hx is less than L plus epsilon. So we can also write it as for every epsilon greater than 0, so there exists delta greater than 0. Combining these inequality, we can write 0 is less than mod of x minus a less than delta, and L minus epsilon is less than gx, and gx is less than L plus epsilon. So for every epsilon greater than 0, there exists delta greater than 0 such that 0 is less than mod of x minus a less than delta, and mod of gx minus L is less than epsilon. So this is the definition of limit. So this tells that if x tends to in deleted neighborhood of a, then gx tends to L. So the limit of x gx as x tends to a is L. So limit x tends to a, gx equals to L, and limit x tends to a, gx also finite, of course. So limit x tends to a, gx equals to limit x tends to a fx, and this is also equals to limit x tends to a hx. So we have proved the sandwich theorem or the squeeze principle. Again we are going to discuss some examples. So first example is example first examples we have first example limit x tends to 0, x square sine 1 upon x. We have to find this limit. So we know that sine 1 upon x, sine 1 upon x lies between minus 1 to 1, minus 1 to 1. So this implies that minus x square is less than x square sine 1 upon x, and this is less than x square. Why? Since x square is a positive real number, so multiplying with x square in inequality does not reverse the inequality, does not change the inequality. So this can be written as like this. So limit x, and also limit x tends to 0, minus x square equals to 0, and limit x tends to 0, x square equals to 0. So the function in the extreme sides going to 0. So limit x tends to middle, the function in the middle also goes to same limit. So limit x tends to 0, x square sine 1 upon x equals to 0 by squeeze principle. Again we have another example. Another example is example 2. Example 2, limit x tends to 0, x square cos 10x. Also we know that the value of cos lies between minus 1 and 1. So this inequality can be written as minus x square less than x square cos 10x, and this is also less than x square. Again x square tends to, so limit x tends to 0, minus x square equals to 0, and limit x tends to 0, x square equals to 0. So limit x tends to 0, x square cos 10x is also 0 by squeeze principle. Thus we have solved the given example. Again we have third example. Example 3 is limit x tends to 0, x square sine 9 upon x minus 2. We have to find this limit. So again we are going to find out this limit. So sine 9 upon x is lies between minus 1 and 1. So x square sine 9 upon x can be written as x square, and this is minus x square. Since this is the positive real number, so inequality does not change upon multiplying with these numbers. So minus x square minus 2 can be written as x square sine 9 upon x minus 2, and this is x square minus 2. Since these are the polynomial, x square minus 2 and minus x square minus 2 is polynomial, so x tends to 0, minus x square minus 2 can be found out by putting the value directly. So this becomes minus 0 square minus 2, and this is minus 2, and limit x tends to 0, x square minus 2 is also 0 square minus 2 and minus 2. So we are looking here that the functions at extreme sides are going to the same limit. So function in the middle will also tends to the same limit at x tends to 0 by the squeeze principle. By squeeze principle, limit x tends to 0, x square sine 9 upon x minus 2 equals to minus 2. So thus we have solved these three examples. We have another one example is fourth. Evaluate limit x tends to 1 fx using squeeze theorem. given that we have given that 5 is less than or equals to fx and fx is less than or equals to x square plus 6x minus 2. So we have to find the limit at x tends to 1. We have to find out limit x tends to 1 fx. So we find out the function in extreme sides and we are going to check that does it satisfy the condition of squeeze principle. So the condition of squeeze principle is, first of all we find the limit of the function in the extreme sides. So extreme side function is limit x tends to 1, 5 equals to 5 since this is constant, and limit x tends to this right side the function x square plus 6x minus 2 is, since this is a quadratic polynomial, we can find the limit by putting the value directly, and this becomes 1 plus 6 minus 2 and this is also 5. So we are looking here that the function in the extreme positions, extreme sides 5 and x square plus 6x minus 2 going to the same limit 5. So fx is also tends to the same limit uh, as x tends to 1 and this equals to 5 by squeeze principle. So by by squeeze principle the limit x tends to 1 is what? Limit x tends to 1 is 5. So by squeeze principle, by squeeze principle by squeeze theorem by squeeze theorem, limit x tends to 1 fx equals to 5. Thus we have solved some problems. So thank you.